For centuries, humanity has looked to the sky in search of answers, building theories, writing equations, and trying to understand our place in the vast cosmic puzzle. Yet everything we thought we knew, our physics, our cosmology, and our understanding of space and time, has been challenged by what the James Webb Space Telescope has observed. According to this narrative, Webb has detected objects and structures that were never supposed to exist, galaxies that appear too old, planets that seem impossibly large, patterns that are unnaturally precise, and even a steady, rhythmic signal that does not fit into any known astrophysical model. This is presented not as just another astronomical discovery, but as a direct collision between long-held scientific beliefs and unexpected observations. The James Webb Space Telescope is portrayed as delivering both a warning and an invitation. If these observations truly represent something beyond our current understanding, they could force humanity to rethink some of the most fundamental assumptions about the universe. Rather than confirming existing theories, they would suggest that reality is far more complex than anyone imagined. During a series of deep-field observations, the James Webb Space Telescope captured some of the most detailed images of the universe ever recorded. Hidden within these breathtaking images, however, researchers reportedly noticed more than beauty. In the galaxy cluster Abell 2744, they identified remarkably aligned points of light and symmetrical structures forming patterns that appeared unusual within the normally chaotic process of galaxy evolution. Meanwhile, observations of the spiral galaxy NGC 1365 revealed unexpected patterns of motion that seemed, according to the narrative, to challenge conventional models of gravitational behavior. The surprises did not end there. Similar anomalies reportedly appeared in multiple observations across the sky. The farther Webb looked into the distant universe, the stranger the cosmos seemed to become. Patterns appeared to repeat across billions of light-years, and structures displayed an extraordinary degree of geometric precision within a universe that was expected to be largely random. At first, scientists attempted to dismiss these features as coincidence, but the recurring nature of the observations led to growing speculation. Some began to wonder whether what appeared to be randomness might actually conceal an underlying order that humanity has yet to understand. Among the many objects observed by the James Webb Space Telescope was the exoplanet HIP 65426b, located hundreds of light-years from Earth. According to the narrative, this massive world left astronomers astonished. Estimated to possess roughly 7 times the mass of Jupiter, it orbits its parent star at a distance approximately 3 times greater than Neptune orbits the Sun. Even more surprising, its host star is only about 15 million years old. Under current theories of planetary formation, constructing such an enormous planet so far from its star in such a short period of time appears extremely difficult. Adding to the mystery, astronomers found no obvious protoplanetary disk or remaining material from which such a giant planet could have formed. Nor was there a clear gravitational explanation for how such a massive world could develop so rapidly while remaining in a stable orbit. These unusual characteristics led some researchers to speculate about alternative possibilities. Could the planet somehow be a remnant of an earlier planetary system? Could it have formed elsewhere before arriving in its present location? For now, these remain speculative ideas rather than established scientific conclusions. What remains is a giant world glowing at temperatures exceeding 1,000 degrees Celsius in a system that appears surprisingly young. One of Webb's most visually spectacular discoveries involved an Einstein ring, a phenomenon created when the gravity of a massive foreground galaxy bends and magnifies the light from a much more distant galaxy positioned directly behind it. In this case, the ring surrounding galaxy J0418 appeared almost perfectly circular. Such remarkable symmetry immediately attracted the attention of astronomers. For an Einstein ring to appear nearly perfect, the alignment between the foreground and background galaxies must be extraordinarily precise across billions of light-years of space. While gravitational lensing itself is a well-understood consequence of Einstein's theory of general relativity, examples of such exceptional symmetry are rare. According to the narrative, this remarkable alignment prompted some researchers to ask whether it might hint at a deeper geometric order within space-time itself, a possibility that remains speculative but intriguing. Perhaps the most controversial claims involve Webb's observations of extremely distant galaxies. According to this narrative, the telescope has identified massive, mature galaxies existing only about 180 million years after the Big Bang. In terms of cosmic history, this is an extraordinarily early period. Standard cosmological models predict that galaxies should still have been relatively small, irregular collections of gas and young stars, rather than large, organized systems resembling the Milky Way. If these galaxies truly possess the sizes, structures, and brightness indicated by the observations, astronomers would need to reconsider important aspects of galaxy formation in the early universe. The narrative goes further, suggesting that such observations could challenge the Big Bang itself. In reality, while Webb's discoveries have encouraged scientists to refine and improve existing models of early galaxy evolution, they have not overturned the Big Bang theory, which continues to be strongly supported by multiple independent lines of evidence. The narrative concludes with another unusual observation. In a region apparently far from any visible galaxy, the James Webb Space Telescope reportedly detected the effects of gravitational lensing despite the absence of observable stars, galaxies, or black holes. Light from even more distant galaxies appeared to bend and distort as though influenced by a massive invisible object. Astronomers have suggested that dark matter, the invisible substance believed to make up much of the universe's mass, could explain such gravitational effects. However, according to the narrative, the observed lensing appeared unusually concentrated and intense.